Hi guys, I'm Niveta. In this video, we are going to see sequence of real numbers. Okay, there are so many concepts we are going to discuss in this chapter. Let's see one by one. Sequence. First of all, what is meant by a sequence? Sequence of a real number is a function. Okay, it is actually a function. Thus, domain is a set of natural numbers and range is a subset of real numbers. So basically, sequence is a function. Those domain contains natural number and those range will be from the range will be real numbers. Okay, real numbers means all kind of numbers. In other words, a sequence on a set R is a rule which assign to each natural number a unique element of R. So a sequence, it is actually a rule. Okay, so rule which assigns for every natural number, it will assigns one unique real number. Okay, a sequence is on a set R is a rule which assigns to each natural number a unique element of R. We have to assign one unique element from a natural number to a real number. Okay, while discussing examples we will come to know. A sequence is usually denoted by an like this or like this. Okay, where fn is equal to an. This is a function. An is called the nth term of the sequence. Suppose I told you no, so it starts from natural number, so you have to start from 1 2 3 like that. So you can put like a1 a2 a3, you will get one corresponding real numbers. Okay, so these are all examples of sequence. Basically, the difference between sequence and series is we used to sequences next numbers. Series means addition of numbers. Okay, so an means a1 means 1, a2 means 2, a3 means 3. Okay, likewise here an means 1. If you substitute 1 here, you will get minus 1. A2 is minus 2. A3 will be minus 3. A4 will be minus 4, like that. Suppose if you are considering 1 here, A1 is minus 1 to the whole power 1 into 1, which is minus 1. Then minus 1 to the whole power 2 into n value is 2, which is 2. Okay, minus 1 to the whole power 3 into 3, which is minus 3. Likewise, it used to come like a sequence. So an is equal to minus 1 power n. This every format is a sequence. Understood? So this is also one kind of sequence. An is equal to 1 plus 1 by 2 plus 1 by 3 plus up to 1 by n minus log n. Okay. Here also you can take like an is the last digit of 3 power n. Cos n is also one kind of sequence. Sin 1 by n is also one kind of sequence. Understood? Okay, let's see some definitions. Range of a sequence. A range of the sequence, the set of all distinct terms of the sequence is called its range. So actually, suppose if you are considering n is equal to minus 1 power n. Okay, if you put n equal to 1, you will get what? Minus 1 power 1 will give you minus 1. If you put n equal to 2, you will get minus 1 the whole square will give you 1. If you put 3, minus 1 to the whole power 3 is minus 1. If you put 4, minus 1 to the whole power 4 will give you 1. Understood? So you are putting one natural number here instead of n. So you are getting one answer. That answer constitutes the range set. The set of all distinct terms of a sequence. The set of all distinct terms of the sequence. Okay, so in that range set you should not put the repeated numbers. So here you have seen like minus 1 1 minus 1 1 minus 1 1, so many numbers are coming, but in that range set you have to put the distinct element only. Distinct means different, so you have to put like minus 1 and 1 alone. Understood? Next, constant sequence. A sequence an on a set defined as an is equal to, here it comes like an is equal to c for all n belongs to capital N is called a constant sequence. Thus an is equal to c is a constant sequence with the range c a singleton. So constant sequence means every numbers, okay, every an constant to only one numbers, constitute only one number. Consider this sequence. An is equal to CC is a constant sequence. If you are considering a range means you have to consider only distinct term. So consider only one thing, which is singleton. So therefore the constant sequence is always a singleton set. Next we are going to see another definition, which is bounded sequence. Okay, sequence an is defined as a bounded if its range set is bounded. Okay, so bounded means just think like there is a real number exist. Okay, so your range set should be less than or equal to that real number. That is what bounded sequence. An is defined as bounded if its range set is bounded. Okay, bounded means there should be one number. The sequence should be less than or equal to that number. Okay, k dash less than or equal to n is less than or equal to k. Okay, fine. Next, supremum and infimum of the range set is a supremum and infimum of the sequence. So if you are considering the supremum and infimum of the range set, means it is actually equal to the supremum and infimum of the sequence itself. Okay, range set means unique element only will be there in the range set. So supremum and infimum of the range set is the supremum and infimum of the sequence. If the range of the sequence an is finite, then there exists alpha belongs to R such that an is equal to alpha for infinitely many values of n. However, converse need not to be true. What does this means? If the range of the sequence an is finite, suppose if you are considering a sequence, those range is finite. Finite means we can count. Okay, then there exists alpha belongs to R. Suppose if the range set is finite, means there exists alpha belongs to R such that an is equal to alpha for infinitely many values of n. See here, example, an is equal to 4. Okay, when we have to put 4 means when n is equal to 1 or any prime number. Okay, when n is equal to 1 or any prime number. So what are the prime numbers? 2, 3, 5, 7, 11, 13. It goes on, right? When you got a prime number, you have to substitute 4. When you got 1, you have to substitute 4. Other than prime number and 1, okay, other than number, you have to put n itself. For example, when you are considering 4 means you have to take the value of an as 4. Okay, suppose if you are considering 6 means you have to take the an of value 6, because for prime numbers and n is equal to 1 only you have to consider the value 4. For other numbers you have to consider the same number itself. What they are telling is, if the range of the sequence is finite, okay, suppose if you are considering one range which is finite, then alpha belongs to R such that an is equal to alpha for infinitely many values of n. Here there are infinite numbers of n out there. Okay, so for those infinite number we are considering only one number, which is 4. Understood? So converse need not to be true means alpha belongs to R such that an is equal to alpha for infinitely many values of n, then there is no need to be, it should be finite, because here also we are having for n, for other numbers it is n. So when you are considering a sequence, you will get infinitely many terms, right? So the converse need not to be true, but for a range of the sequence, if you need to be a finite, you have to tell one alpha belongs to R such that for the sequence we have to equate it to that number for infinity values of n. Okay, an is equal to 4 for infinitely many values of n, but range of the sequence is not finite, right? So for prime numbers, all prime numbers, it is 4 only. Understood? An is equal to 4 for infinitely many values of n, but range is not finite, because we are other than prime numbers, there are so many numbers, there are so many composite numbers like 4, 6, 8 and all. For those number, that same number will come, right? Therefore we can't say that the range set is finite, so it is not finite. Understood? Next we are going to see cluster point or limit point of a sequence. A real number L is said to be a cluster point of a sequence an if for a given epsilon greater than 0, however small, and for a positive integer m, there exists positive integer k greater than m such that ak minus L is less than epsilon, that is L minus epsilon is less than ak is less than L plus epsilon. Okay, this is very important. Okay, we are going to see limit point of a sequence. We are going to see what limit point of a sequence. So for that what definitions they have given. Most of us in our previous class we used to by heart those things, but no need to by heart that number. Okay, we will get to the point. Understood? So first is cluster point. We have to limit point of a sequence. Okay, just consider uh, what they are telling is L is said to be a cluster point. Okay, you just consider one sequence. You just consider one sequence. That sequence may have any values. Okay, that sequence may be like anything. Mm, Suppose if you are considering a sequence like this. Okay, suppose if you are considering the numbers which comes like this. Understood? So here L is said to be a cluster point of the sequence AN. This is a sequence AN. Okay, we will say that L is a limit point of the sequence for epsilon greater than 0, however small for a positive and for a positive integer m, there exists k greater than m. Okay, such that ak minus L is less than epsilon. What they are trying to tell is, see, ak lies between L minus epsilon and L plus epsilon, right? So if you are considering L as here, so L plus epsilon will be here, L minus epsilon will be here. Okay, L plus epsilon, if you are drawing a line, it will be like this, it will be like this, L minus epsilon. Understood? So L lies between L plus epsilon and L minus epsilon. So here what they are telling is AK lies between L minus epsilon and L plus epsilon. So just consider this as L plus epsilon and L minus epsilon. Okay, wow. Then what they are telling is just there is one positive integer m. Okay, so just consider this as 1 2 3 and goes on. Okay, there at one point, okay, at one point consider this point as m. At one point, after that what will come? M plus 1, m plus 2, m plus 3. It goes on like that, right? It goes on like that. After, what they are telling is after a particular point, okay, k greater than m, okay, after a particular m, what exists is ak minus L is less than epsilon. So the difference between this ak means what to say, this is an, right? Ak means some sequence, up to some limit. Okay, so ak and this L is a point here, right? So the distance between, okay, if you are considering this, the distance between this AK as well as this L will be very less, that is what it converges, right? After sometimes it will converge like this, right? Can you understand what I'm telling? What they are telling is L is a cluster point of the sequence. Here you are having a point L. L we will say like limit point or cluster point of a sequence. When there exists a for epsilon greater than 0. Epsilon greater than 0 means it is a positive value, however small, but that epsilon is very small. See here, L plus epsilon. See that epsilon and all we have to see it in microscope, that much small, but that is a positive quantity. Okay, so it is L plus epsilon and this is L minus epsilon. Understood? Epsilon greater than 0, however small, and for a positive integer m, you have to consider one positive integer m. There exists a positive integer k greater than m. There exists a positive integer k, that k lies here. Okay, here it goes on. There exists k which is greater than m. Okay, ak minus L, modulus of ak minus L is less than epsilon. So at this point the sequence an sequence is ak. At this point the an sequence will become ak. Okay, the distance of ak and the distance of L is less than epsilon. Epsilon itself a very small quantity. I told you, right? We have to see it in microscope. At one particular point, after that point itself, after the ak point, the sequence ak and the point L, okay, the distance between ak and L will be less than epsilon. Can you understand? So L is a limit point or cluster point. Okay, we have to consider L plus epsilon and L minus epsilon after one particular point M. After that there exists a point K. At that point, okay, the sequence AK. Okay, at that point there exists a sequence which is named as AK. AK and the L, the distance between those two things will be less than epsilon. Okay, So that is what, if that exists, means that L is termed as cluster point of the sequence. L minus epsilon is less than AK is less than L plus epsilon. At one particular point, it comes very close. It comes very, very close. Okay. So that is known as limit point. L belongs to R. It is a real number and it's a cluster point of the sequence. If and only if neighborhood of L contains infinitely many terms of the sequence. Please remember, so neighborhood of L. So here in this L, okay, there should be infinitely many numbers should be there. Okay, so the neighborhood means nearer to that point, there should be infinitely many terms of the sequence should be there. Limit point of the sequence is different from limit of a sequence. Here we have considered limit point. For that limit point, the neighborhood should exist. Infinitely many terms should exist. But for limit point is different from limit of a sequence. Okay, limit point of a sequence is different from limit of a sequence. See here. Suppose if you are considering a sequence minus 1 power n. Suppose if you put 1, you will get minus 1. If you put 2, you will get 1. Minus 1, 1, minus 1, 1, minus 1, 1. Here the limit points are minus 1 and 1 only. See, suppose if you are considering sequence n means 1, 2, 3, 4, it goes on. So it has no limit point. Okay. Next we are going to see limit of a sequence. A and B the sequence, L belongs to R. L is said to be a limit of the sequence AN. L is said to be a limit of the sequence AN if and only if for every epsilon greater than 0, there exists M belongs to R, M depending upon epsilon, such that An minus L is less than epsilon for all n greater than or equal to M. So here what happens here is the sequence An exists. Okay, L belongs to R, which is a real number. We will say L is a limit of the sequence. This is limit point. Limit point should have the neighborhood. But here L is a limit of the sequence if the same epsilon greater than 0. I told you in the above, right? Epsilon is a very small quantity, but it is a number which is greater than 0. There exists M belongs to N. M is a natural number. I already told you, right? So here we are getting the value like 1, 2, 3, 4. So M should be belongs to N. N. M depending upon epsilon, such that An minus L, that An is this sequence, right? An, the distance between An minus L should be less than epsilon. Okay, it is a very, 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 very small point. It should be less than epsilon for all n greater than or equal to M. Okay, so we are having one n, right? This n should be greater than or equal to M means after that one particular M only, that An exists, that the distance between An and L will be less than epsilon. Okay, so here it denotes the value L. But here it denotes the neighborhood. Understood? Next, algebra of limits. Limit n tends to infinity, An is equal to A. Limit n tends to infinity, Bn is equal to B. Okay, suppose if the condition given like limit n tends to infinity, An is equal to A, and limit n tends to infinity, Bn is equal to B, like that condition, if suppose it's given, means you have to take it as limit n tends to infinity, Kan is equal to Ka. Understood? So because limit n tends to infinity, An is equal to A, right? So limit n tends to infinity, An is equal to A. So K is a constant, you can write it like this. Then limit n tends to infinity, modulus of An is equal to modulus of A. These are all results. Limit n tends to infinity, An plus Bn will give you A plus B. Limit n tends to infinity, An minus Bn will give you A minus B. Limit n tends to infinity, An Bn will give you AB. Limit n tends to infinity, 1 by An will give you 1 by A. Limit n tends to infinity, An by Bn will give you A by B, where B is not equal to 0. There are some results. Okay, this and all you have to remember to check whether for a sequence. Okay, if P is greater than 0, this P, no. If this P is greater than 0, limit n tends to infinity. This number tends to infinity. It goes on to infinity. Suppose if this P is greater than 0, then this value will be equal to 0. if p is greater than 0, then limit n tends to infinity, root of np is equal to 1. So here it is 1 by np, but here it is root of np. Okay, so for the value of p greater than 0, for this limit n tends to infinity, root np is equal to 1. Here limit n tends to infinity, root n is equal to 1. Okay, then if p greater than 0, limit n tends to infinity, n square divided by 1 plus p power n is equal to 0. If this kind of a problem exists, means the value of p, when the value of p is greater than 0, when the value of p is greater than 0, this value it's said to be 0. If modulus of x is less than 1, limit n tends to infinity, x power n is equal to 0. Then limit n tends to infinity, 1 plus 1 by n to the whole power n is equal to e. This is a famous standard format. Okay, 1 plus 1 by n to the whole power n, where limit n tends to infinity will give you e. Next, monotonic sequence. A sequence an is said to be monotonically increasing if an plus 1 is greater than or equal to an. So, which means next term. Okay, for all n belongs to capital N. That is a1 is less than or equal to a2, is less than or equal to an, is less than or equal to an plus 1. The thing is, the first number is very small. It goes on. Monotonically increasing means it will be like this. Okay, for if 1 2 3 it increases, means this also should increase, a1 a2 a3, this also should increase. That is what monotonic increasing. Monotonic decreasing means, suppose if this number increases but this number decreases, right? This is decreasing, the function is decreasing for this increasing. Okay, here this also increasing, this also increasing. For here, when this is increasing, this is decreasing. Understood? That is what monotonically decreasing, and this is monotonically increasing. Okay, that is the condition. a1 is less than or equal to a2, and it is increasing. A sequence is monotonically decreasing if an plus 1 is less than or equal to an. The next terms will be less than the before term. Okay, the next term will be less than the before term. For see here, it is the first term, which is the highest term, highest number. See here, for this it is the highest, and for n equal to 1 it is the highest, and after that it is getting down, right? So that is what a1 is the highest, and greater than or equal to a2, greater than or equal to, like that. Okay, it is monotonically decreasing. Then a sequence is said to be monotonic. When a sequence is said to be monotonic, either it should be monotonically increasing or monotonically decreasing. Understood? Strictly monotonically increasing means what? Here we are having greater than or equal to. Okay, but in strictly increasing it should be like greater than only. Strictly decreasing means less than only. Understood? Here you are having equal to symbol, but here you should not have that equal to symbol. Okay, a sequence an is said to be strictly monotonic. Okay, means if it is either strictly monotonically increasing or strictly monotonically decreasing. See here, it is strictly increasing sequence. an is equal to n means 1 means 1 2 3 4 5 6, so it's like increasing. Minus n means what? It comes from infinity, like it comes up to when the value increases, minus 1 minus 2 minus 3 minus 4, it's like decreasing, right? So that is strictly decreasing. Minus 1 power n is non-monotonic sequence, because when you put 1 you will get minus 1, when you put 2 you will get 1, when you put 3 you will get minus 1. Okay, it's like it is not increasing as well as it is not decreasing, so it is not a monotonic sequence. Okay, next we are going to see convergent sequence, Cauchy sequence in another video. Thank you for watching. If you like this video, please share, subscribe to my channel. Your each like and each subscription is very important to me, and your comment is very important to me. Please extend your content in below session. Thank you for watching.